want to sit? Welcome, everyone. So, welcome to day 4 of reInvent 2025. So, we are super excited to present to you in this lightning talk on how Fidelity Investments implemented an enterprise-scale text-to-SQL solution that can convert natural language into precise queries to derive actionable insights. So, excited to be here and happy to introduce the Fidelity Investments team.
Thank you, Vikram. My name is Manish Warlikar, and I head AI Center of Excellence for one of the business units in Fidelity called Fidelity Institutional. Ray, you want to introduce yourself?
Yeah. Good morning, everyone. My name is Ray Zhang. I lead the Text-to-SQL implementations.
Sure. So today what we will do is we'll cover our journey from identifying and confirming the business problem to actually technical details that Ray Zhang will cover in later. Right? So
Okay.
Okay. So we'll start with the journey. So our approach is more user-centric. What we did is we observed our users of how they are interacting with the data. We saw that what we saw is they are using multiple applications. Think about CRM, dashboard, Excel, and piecing together the data, and also many times calling a friend or some other team members trying to get understanding of the data, right? So what we found out is that it is not the problem or the challenge with the data. What we discovered was it is the access to the data. That is the bigger challenge, right? So what we also understood that this problem that we face is not unique or isolated pain point. It is more like, it is applicable to multiple enterprises where data is more, scattered, complex. The SQL is a good language, it's like powerful language, but the thing is, there is a technical dependency with the technical team, and on the other hand, the business needs a very intuitive data access, like quick, faster, data-driven insights, right? So this picture at the center actually will help you understand why the challenge persists, right? As you see, data at the bottom, and as the data travels towards the user, think about the data has to travel through multiple layers, right? Think about layers as data preparation, data transformation, and then eventually get served via a UI channel. Think about dashboards, think about application UI to the user. So as the data is kind of moving along the layers towards the user, it is getting more fixed, more rigid and templated, right? But on the other hand, the user questions are smart and flexible. So just wanted to pause here and kind of ask you all that does it sound familiar, similar to you? That do you see this is in your enterprise, right? Raise your hand if you see it, right? So yeah, I do see it. So basically what we thought is, instead of doing this, what if we do one thing? Bring the user question directly to the data, right? And that led us to a natural language to SQL query capabilities. And we said, okay, we need to build this capability. What this helps is it totally changes the game, the way we approached it, right? It democratizes the access to the data. It also reduces dependencies on the SQL experts. It also, imagine multiple personas within your organization actually get enabled with this data access, right? It kind of raises the floor of your organization when it comes to insights from data. And also, business is able to now quickly get data-driven insights to make informed decisions and create business impact. With this, what I will do is I'll pass on to Ray Zhang to talk about technical details, right?
I'm going to talk about our technical implementation of text-to-SQL systems. I will detailing the architecture we build. So our implementation is based on the 3 pillars of intelligence. The first one is AI-ready data. AI-ready data is the foundations, right? It's just like you structure the data like you wanted to make it both understood by the humans as well by the large language model. The second one is the semantic layer. Semantic layer, the translator, translate the business language into database terminologies. And the last one is the dynamic workflow, which is manage the entire process for the user input in natural language to executable queries. So these 3 components need to work seamlessly. and the user can get the data they need without writing single lines of code. So now we're going to first start with looking at the foundation, about data and the semantic layers. So to make it data ready, we follow these 4 principles. The first one is use consistent naming conventions and use a stronger relationship foundation. Just to make sure, like, what does it mean? Like, every table should have an identity. You need to explicitly define the primary keys. And also, the foreign keys need to be explicit instead of implicit. These will allow the LM to navigate around the data using the relationship. And a single source of truth. The last one is make it use the product hierarchies. So for example, like if you have the investors' accounts and holdings, and if you mirror this design, this data will be instantly understood by the LM. And if you ask a question, what is the total AUM for this, total portfolio value for this investor, the LM should direct the queries to the investor holding table, to investor profile table using the pre-aggregated data instead of generate a complex aggregation SQL. So these semantic, the AI, those principles can feed directly into the semantic files. In our semantic layer, data is represented, this information is represented in a semantic files. As you can see, this is using investment manager example. We have 3 tables, right? There is a funds information, investor profiles, and also there is investor holdings. Every tables, they have a list of columns. Each column have a list of attributes. Every piece of information just to add additional information for LM to understand. You can see there is a business descriptions, which is bridging the language gap, right? And then their example value just to allow the model to see the shape of the real data. The synonym is to just bridge the language gap. And also for this dimensional columns, we also just have the attribute called distinct values, because you want to preserve the value as this, so that when they perform the filter, they can perform the filter logic correctly. And finally, we also encode the relationship. Yeah, here, like these 2 investor profile and investor holding has a one-to-many relationship. This will help the LM to write the join clause correctly. Now, with this, to create those semantic file manually is like a tedious task, error-prone. So we actually build tools to automate generate semantic files. This the block diagram just show the whole workflow. The one thing I want to point out, this is the last step which is very crucial, is just like there requires human review of this business descriptions and the synonyms. Also, this is iterative process, right? Sometimes if you find the generative sequence incorrect, you want to go back and fine-tune this semantic file. And sometimes you might have to even go back and update the schemas. So now we have the foundations. We're ready to talk about how do we process the intelligence queries. The first step is just look at the query rewrite. User does not always ask perfect questions. So the query rewrite is just bridging the gap between the user vague intent and executable, like precise queries. So when user question, when it comes in, this query rewrite is just to determine is their question is clear. Do I have the data to answer this question? And which part of data you need to answer this question? Based on this result, it has 3-way decision making, either to accept, reject, or clarify. So for example, based on the investment profile example, if the user asks a question, what fund is going to perform, like is it going to outperform next quarter? These are predictive questions, right? And then we only have historical data, and the system should respond, should stop it early. But if the user asks the question, okay, what is the best fund? This is like an ambiguity in the question. The system should respond, Do you mean by AUM or by particular like asset class? So with query rewrite, user doesn't have to understand underlying the column name. He can speak naturally, and the system does the translations. Right? Basically is teaching the user and the system to communicate better. So now the question is clear. We're going to talk about the most complex, important part of the workflow, context engineering. The context engineering is the difference between the AI that delivers and the AI that guesses. In our implementation, the user question is combined with 6 semantic components. That's including the system prompt, question-specific schema, teaching examples, entity values, and the output format, right? Which is a response how do you want the LLM to respond, and the tools used. The context assembly is just to assemble this component together to create a precise prompt, and used for the SQL generations. The one important challenge is for context engineering is about the manage the size of context windows, right? So in the enterprise database, you can have hundreds of tables, 1,000 columns. The resulting semantic file could be easily over 100 Ks. It's impossible to inject all this information in the context window. So we act the actual step, just called sending those condensed format to the LLM and ask LLM to tell us what tables and columns are needed to answer these questions. So, and then we filter out everything else. This will result, the following, like the payload will be 90% smaller, but 100% relevant. So another things we know, like LM learns by the teaching examples, through the in-context learnings. So we do have like memory stores, in-memory stores to manage like a validated SQL and the question and SQL pairs. And we have whenever like a user question comes, it's going to evaluate what are the most 3 similar questions based on the user question, and it will insert it into the context. So when LLM receive this as examples, they should be able to generate SQL that align with the best practices. And we also put a monitoring system in place just to capture all the interactions between the users and the systems. And we use LLM to judge, evaluate those queries to see if there anything that looks suspicious. And then we have the human expert periodically review those questions that might be problematic. If indeed there's errors, we're going to fix examples and insert it into the store. As you can see, this is like a continuous learning loop, right? In the bottom line, is kind of like you have SQL experts that remember all the query he write, learn all the mistakes they made, right? Over the time, he's just expanded knowledge. So we are building an institutional memory that ensures the future query is always going to be smarter than the past. So another important technique we use is just use entity search, because the users prefer to use like shortcuts, use abbreviations. So how do we leverage it? We talked about earlier in the dimensional column, we're trying to store all the values, database values in the distinct value. But in the enterprise database, you could have many entities, and each one have 1,000 values. So what he said we are doing is we take an actual step, put all these entity values into a vector store, and perform a semantic match. Only those top matches get inserted in the context windows. So this has come to the final stop. Now we have the context ready. We're going to send it to the LM for SQL generations. So we do put some security guardrails in place to make sure there's only select only syntax. There's no delete, insert, or update. And also we have 16-point instructions to telling the LM how to perform the join, how to create the where clause, and other rules. So when the SQL came back from the LM, we also perform the syntax check, right? If the syntax is error, we're going to send the error message along with the original question to the LM for retry, with up to 3 times the retry. So only, as you can see, only the validated and syntax correct SQL will reach the database. Our process is sound, but one thing that we found out, like it's counterintuitive, but I would like to share with the ones. We found out that more example actually hurt more performance. So we used to start with have like this example stash has over 100 examples. The accuracy is not that good. What we found out is many of these examples, right, like is unnecessary. The LM is a perfect fine to generate correct SQL without them. So we trim those examples to only 30s. But all the remaining examples that they have to exist for a reason. Either is addressed as edge cases, teaching a business rules, right? This is just kind of like have a high signal guidance with a low noise. So these example is just basically teaching the model to how to think. We also spend like quite a significant amount to build this test suites, because this is important as it provide quality gates, right? Like a test, if every time when we upgrade the model versions or like add new data sources, we need to repeat this test just to ensure there's no regressions. So these are like those example test suites to prove this model doesn't work. So now we'll look at the performance, like how was the current performance. We're using the Anthropic, like the Bedrock Anthropic model, Clause 74. We measure the performance in 3 dimensions. The first one is execution accuracy, which is measure the row count between the targeted SQL and the actual and the generated SQL. Right? Currently we stood at 93 to 95%. And the result set comparison is just use LM Judge to compare the first 500 rows between the target and executed SQL. And right now is about 89 to 92%. The average response time is 28 seconds. The response time not only just a measurement of the user experience, also measure we use token space. The token usage is efficient. And this is our how the performance evolve over the time. We didn't get this number on the day one, right? This is a continual improvement, and make sure the model continues learning how to expand the knowledge. How do we get where we are now? So this comes to the final, just how do we lessons we learn. We try the different things, so you don't have to. So what do we think we find out works is that using deterministic workflow. So this is a predictive workflow, and more reliable is a production ready on the day one. And also use a clear schema. Just make sure the schema is structured and well documented. So these will prevent interpretation errors. And the surgical teaching examples, just make sure every example exists for reasons. The quality is more important than quantity. The optimized context, right? So to make sure you just send enough information to the LM, then nothing extra. So the bottom line is like a simple, well-engineered the system will outperform the shiny and complex ones. That's towards the end. And thank you everyone for your time, attention. We'll be at the site, but feel free to come over if you have any questions. Thank you. Bye-bye.
Thank you.